Hi, this video is going to look at haloalkanes from the OCR A-level spec. We're going to look at the hydrolysis of haloalkanes and then also some environmental concerns about them. So, beginning with just a haloalkane, these are alkanes that contain a halogen. So it could be chlorine, bromine, fluorine. It might be one of them, two of them, three of them, so on. So with haloalkanes, which I'm just going to use X to represent my halogen for the moment, they undergo hydrolysis. So if we take an aqueous solution of hydroxide ions, usually sodium hydroxide or potassium hydroxide, in this I'm going to use sodium hydroxide. I'm going to heat this, I tend to say heat it under reflux. This is aqueous. Then, that just frees up all our OH minuses. That leads to a substitution reaction where the X disappears and gets replaced by an OH. Oh, I've called it CL. And our halogen, that then joins with whatever was the metal ion in our hydroxide. So it must be aqueous, or it won't work, and it's got to be heated, and we say under reflux. So reflux is a specific type of practical that you should see in the practical techniques section. So that's the equation we've got here. This is known, and we said before, it's a substitution because we're replacing one thing with another thing, and this is nucleophilic because we're going to use a nucleophile. So a nucleophile is an electron pair donor. So we'll look at that specifically in the mechanism that we're going to do now. So I have my X and my H there. And now halogens are generally pretty electronegative, especially fluorine and chlorine. So we create in this a dipole where we've got our positive then carbon and our delta negative halogen. It just means the electrons are being pulled towards that X. Now our OH minus, because it's aqueous, we have OH minus, then has got that electron pair. And now this is our nucleophile. It loves nucleus or positive charge. What's going to happen here is this electron pair, because it's going to be attracted to that delta plus, just move the delta plus to the other side. Carbon is going to come in and form a bond with it. It's going to donate the pair of electrons into that bond between the carbon and the oxygen on that OH. Now carbon can only have 4 bonds, so the weakest one is going to break off, which is that bond between the C and the X. So that breaks off. And that creates our product that we see up here. We'll have now an alcohol forming. And the X will now have gone off and it will have taken 2 electrons, so we'll have X minus as our other product. So that is nucleophilic substitution. Next up, we are going to look at, done the Haloalkane mechanism, brilliant. So we can now look at the environmental difficulties with haloalkanes. And specifically,